Hello everyone. In this video we're going to be solving a radical system. I'll be presenting two methods. Let's start with the first one. So now we do have this system x plus y minus the square root of xy equals 7 and x squared plus y squared plus xy is equal to 133. So for our first method I'm going to isolate the square root of xy from the first equation. If I go ahead and add it to both sides and subtract 7, I get the following. And then I'll be squaring both sides. When I square both sides, I'm getting xy equals. Now I can just consider this as a single quantity and write this as x plus y squared minus 14 times x plus y plus 49. Now, it's better to leave it like this because we're going to turn this into a different system. And you're going to see that in a little bit. So I'm not going to expand x plus y quantity squared. Okay, my second equation can also be manipulated. So I can replace x squared plus y squared with x plus y quantity squared minus xy or minus 2xy. But then there's a xy here. So I can just write it as minus xy equals 133. Now this is my new system, and notice that this system is in two variables. One of them is x plus y, the other one is xy. So I'm going to call the following: x plus y, let it be s for sum, and xy, I'm going to call that p for product. And then I get the following: p equals s squared minus 14s plus 49. Second equation gives me s squared minus p equals 133. Now, since both of these equations have p as a linear term and there's no squares, as first powers, we can just set them equal to each other. So let's go ahead and isolate the p from the second one. This is what p equals from the second equation, and I'm going to substitute that into the first equation. Let's go ahead and do that now. So if we do that, we're going to get s squared minus 133, that replaces p here, equals s squared minus 14s plus 49. Obviously here, s squared cancels out, and we end up with a really nice equation. Add 14s, add 133 to both sides, you get 182. And if you divide both sides by 14, you'll notice that s equals 13. And now if we go ahead and plug in 13 here, we find that p is equal to 13 squared, which is 169, minus 133, and that is equal to 36. So our system of equations gives us another system of equations as a solution, because s is the sum, so we get x plus y is equal to 13, and xy is equal to 36. Now this is a system of equations that turns into a quadratic equation. For example, if you go ahead and replace y with 13 minus x, you get x times 13 minus x equals 36. And then by distributive property, you get the following, and put everything on the same side. Then you're going to be getting x squared minus 13x plus 36 is equal to 0. So you can proceed as follows and solve for x, and obviously for y as well. And since x and y are interchangeable, when we solve for x, we're basically finding all the values for x comma y. Now, you can also look at this equation from another perspective. If you consider this system right here, we're kind of talking about two numbers whose sum is 13 and whose product is 36. And obviously, those numbers are very easy to find, right? I know guess and check is not liked by everyone, but if you solve the quadratic by using the formula, if you don't like guess and check, you'll find the same answer. So from here, we can safely say that, hey, 9, 4 satisfies the answer, as well as 4, 9. But let's go ahead and check this quadratic equation. Let's see what it gives us. X equals negative b plus minus the square root of b squared, which is 169, minus 4ac, which is 144, divided by 2. And from here, this gives us 25. The square root of 25 is equal to 5. And from here we get 13 plus 5 divided by 2 and 13 minus 5 divided by 2. As you know, this is equal to 9 and that is equal to 4. So we get the same answer no matter what. So we got two solutions from here, 9, 4 and 4, 9. This concludes the first method. Let's go ahead and take a look at the second method. Now our second method is, I think, also interesting because it uses a different idea. All right, let's take a look. So here's what we're going to do for the second method. Let me rewrite my system. Then I got x squared plus y squared plus xy is equal to 133. Now, here's how the second method works. First of all, if you knew that 133 is a multiple of 7, that would be kind of helpful because 7 times 19 is 133. You may or may not know this, but that's okay. Now, here's how the second method proceeds. If you look at the second equation carefully, I can kind of write it, and we actually did it like that before, but we didn't really proceed. So we can write it as x plus y quantity squared minus 2xy plus xy is equal to 133. And here, if you simplify, you get the following. So what's so special about it, right? Well, here's the thing. Look at the first equation and look at this one. Now, the second equation here can be factored by using difference of two squares. Awesome, let's do it. So I can safely say that this can be written as x plus y squared minus square root of xy squared. And this allows us to write it as a difference of two squares. Let's go ahead and do it. So we're kind of able to factor it, even though it doesn't look factorable. And we know that x plus y minus square root of xy is equal to 7. So this is equal to 7. And by division, you find that this is equal to 19. Awesome. That gives us another system. Let's go ahead and solve it. This is 19, and this is 7. Right. Now, if you solve this system, obviously, it's very easy to solve, by the way, you're going to find out that 2x plus 2y is equal to 26, which means x plus y is equal to 13. And if you substitute 13 into one of these equations, doesn't really matter, let's do the first one, then you get the following. You're going to get the same results, right? Square root of xy becomes 6, and by squaring both sides, you get xy is equal to 36. Great. So now we get the system x plus y is equal to 13, and xy is equal to 36. So you're kind of looking for two numbers whose product is 13 and whose sum is 13 and whose product is 36. And as you know, those numbers are 9 and 4 or 4 and 9. And this brings us to the end of this video. Well, thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.